So in this video, we're going to calculate the arc length of a curve over a given closed interval, and we're going to do the calculation with respect to the x-axis. So the interval over which we're going to work is going to be an x-axis interval. So here the example says, find the arc length for the graph of f of x equals x to the fourth over 8 plus 1 over 4x squared on the interval where x runs from 1 to 3. So what we want to remember, if we're going to find arc length with respect to the x-axis, or we're going to work with dx, then the formula for arc length is going to be given by s, arc, which represents arc length typically, equals, and it's going to be the integral, and we run the integral from 1 to 3. And this comes from the formula that we developed in video 1. So if you haven't watched video 1, you should at least fast forward through video 1 and write down the formulas that we developed in that video, because those are the formulas that we'll be using moving forward. So the arc length is going to be calculated by taking the interval from 1 to 3 of the square root of 1 plus the derivative of f of x squared dx. So we can see that we're going to need to take the derivative, we're going to need to square the derivative, we're going to need to add 1 to the derivative. So there's a bunch of scratch work in here that I would suggest that you do before you actually try plugging things into the square root symbol. I would do as much simplification ahead of time as I could possibly do. So over here I'm going to take my f of x, which is equal to x to the fourth over 8, and this is plus 1 over 4 x squared, and we know we need to calculate the derivative of f, so I need to know f prime. So f prime is going to equal, we'll bring the exponent down in front, and then when we bring the 4 down, it will go into 8 twice, and then we reduce the exponent by 1, so we wind up getting an x cubed over, the 4 is going to come down and go into 8 2 times. And here, if it helps you to think about it, you don't need to do this, but if it helps you to think about it, with this x squared in the denominator can be rewritten as x to the negative 2 in the numerator. And so we know when we take the derivative of this term, the negative 2 is going to come down, which is going to give us a minus. A minus 2 is coming down, that 2 is going to go into the 4 2 times. And then we need to decrease this exponent by 1. So we do negative 2 minus 1, which is going to be a negative 3. So we get x to the negative third power. And then what we know next is, once we found the derivative, which we just did, we're going to need to square the derivative. So we might as well do that now before we dump everything in here. Otherwise we have to drag the square root and the integral sign down the page. So sometimes it's easy to do some scratch work off to the side first. So we're going to need to square this. And to square this, it might be useful if we move, it might help us to think about it. If we remember that if x to the negative 3 is in the numerator, we can rewrite that as x cubed in the denominator, and that's going to leave us a 1 in the numerator position. So if we square this out, we're going to get x squared over 2 times itself, which is going to be x to the 6th over 4, minus, we're going to get this times this twice, so we're going to get 2 times the product of x cubed over 2 times 1 over 2x cubed, and then we're going to get minus 1 over 2x cubed times itself, so we're going to get a minus times a minus is a plusy, and 1 times 1 is 1, and 2x cubed times 2x cubed is going to be 4x x to the 6th. And then we can simplify this middle term a little bit, so we have an x to the 6th over 4. And then this is going to be, it's going to be x cubed divided by x cubed, which equals 1 as long as x isn't 0. But on the interval from 1 to 3, x can't be 0. So we see x cubed divided by x cubed is 1. and 2 divided by 2 is 1. So we're going to be left with 1 times 1 times 1 over, and all we have left in the denominator is the 2, and we'll bring down the 1 over 4x to the 6th. So right now I know what the square of the derivative is. That's what I just calculated. But here I can see that I'm going to need to add 1 to the square of the derivative, so I might as well do that now. So if I take and add 1 to this, I see that I'm going to need to combine it with the minus 1/2. So I'm going to go 2 halves, which is 1, plus x to the 6th over 4 minus 1/2 plus 1 over 4x to the 6th. And so we'll get 2 halves minus 1/2 is going to leave us with 1/2. We get x to the 6th plus 1/2. X to the 6th over 4, sorry, plus 1/2 plus the 1 over 4, and this should be x to the 6th coming down here. So 4x to the 6th. And things are always contrived in calculus, and at least in first year calculus. So you've got a square root here. You've got a square root here. And if things are going to work out nicely, we need something squared under here so that we take the square root of something squared. So what I would do next is look at this and say, is it possible to write it as something squared? And the candidate would be to take the x to the 6th and make that x to the 3rd, and the 4, the 2 squared is 4. So x cubed over 2 times x cubed over 2 is x to the 6th over 4. So squaring x cubed over 2 would give me this back. And I've got all plussies, so I'm going to put a plussie in here. And this, 1 squared is 1, and 2x cubed squared is 4x to the 6th. So the question is, when I square this out, do I get the 1/2? And we need to check that. So the check would be to take x cubed times 2 times 1 over 2x cubed, which when we square this we get 2 times, and see if that simplifies to 1/2. So what is 2 times the product of the 2 terms inside the parentheses? So it'd be 2 times x cubed over 2 times 1 over 2x cubed, and x cubed over x cubed is 1 as long as x isn't 0. X isn't 0 on the interval from 1 to 3. 2 divided by 2 is 1, and indeed this simplifies to 1/2. So if we square out this binomial that we've written, we'll get back the previous line. And so now I've got something squared, and now I think I'm ready to go ahead and pop that. This is my scratch work here. I'm ready to pop this result into this underneath the square, the radical sign. So the arc length is equal to the interval from 1 to 3 of the square root of our x cubed over 2 plus 1 over 2x cubed, all squared, dx. And the square root of the square root is going to cancel the squaring, and I don't need to worry about absolute value signs because the sum in here is positive for all x on this interval. So I can just drop things down. I can say the square root cancels the squaring, leaving me with x cubed over 2 plus 1 over 2x cubed, and this is dx. And now I think I'm ready to integrate. So when I integrate this, when we integrate, our guess is going to be the exponent's 1 bigger. So we'd say, hey, this needs to be an x to the 4th kind of thing when we integrate x cubed. But if I take the derivative of this, I need to get this back. And this has a 2 in the denominator. So I'm going to need to put an 8 in the denominator, because when I take the derivative here, the 4 will come down and go into the 8 twice. And then we reduce the 4 by 1 to get 3. So the derivative of this is what I started with, x cubed over 2. So this is correct. And then I'll move to the next one here. And it might be easier to think about this if instead of writing it 1 over 2x cubed, we write it as x to the negative 3 in the numerator. And then we say, hey, when we integrate, this exponent needs to be 1 bigger, and the number that's 1 bigger than -3 is -2. So I'm going to have an x to the -2. But when you take the derivative of x to the -2, the -2 would come down and give me a minus right here. So to get a plus, I'll need a minus. So when the -2 comes down, I get negative, and negative is positive. But I need a 2 in the denominator, so I'm going to have to put a 4 down here. So when this -2 comes down, the negative makes the minus a plus, and the 2 goes into 4 2 times. And then this is going to go from 1 to 3. So now we plug in our limits of integration. So this is going to be equal to, 3 is going to go in here. We get 3 to the 4th over 8 minus 1 over 4 times. So I'm going to write this with the x to the -2 we'll put down here. So if it's x to the -2, I can also write it as 1 over, we had 4x squared. So x to the -2 can go down into the denominator. We make the exponent positive, and then we're plugging 3 in, so we get 4 times 3 squared, and then it's going to be minus, and then we plug in the 1. So 1 to the 4th is 1/8 minus, plug in the 1 here, we're just going to get a quarter. And now it's just a matter of simplifying. 3 to the 4th is 81, so we get 81 over 8 minus 3 squared is 9 times 4 is 36. Distribute the minus into the parentheses, we get minus an 1/8 plus, might as well get a common denominator on the 1/4, so minus minus plus, and a quarter is the same as 2/8. So doing the stuff first with the common denominators, we get 81/8 minus 1/8 plus 2/8 is going to be 82/8 minus a 1/36. And then I'm going to come up here because I'm kind of out of room. Give myself some space here. So continue to simplify. I have arc length equals 82 over 8 is going to reduce to 2 goes in there, 41 fourths minus the 1/36. So to get a common denominator, I need 9 over 9. So this is all going to be over 36. And it's going to be 9 times 41 is going to be 340. 9 times 4 is 36. We're going to get 369 minus a 1, which is going to be the 368 over 36. And that should be reduced. It looks like 4 goes into 36 9 times, and 4 goes into 8 twice, which gives me a 92, and 4 will go into 36 9 times, and that looks like it has been simplified. So we get arc length equals 92/9, as long as we didn't make an arithmetic error along the way. But this is the gist of it. This is conceptually, this is what we need to do to solve this problem.